sklearn, features election, sequential feature selector. Description. Sequential feature selector is a feature selection method that iteratively adds or removes features based on a specified scoring function. It can be used for both feature selection and dimensionality reduction. There are two main variants: forward selection, which starts with an empty set of features and adds one feature at a time, and backward elimination, which starts with all features and removes one feature at a time. Inputs. Estimator, the machine learning model to use for feature scoring. This can be any estimator that has a fit method and a score method or predict proba for. Classification tasks. N features to select the number of features to select. If auto, the number of features will be determined by the scoring function. Direction, the direction of feature selection. It can be forward add features or backward remove features. Scoring, the scoring function to use. This can be a string-like accuracy, F1, Rockock, or a custom scoring function. CV, the cross-validation strategy to use. This can be an integer number of folds, a CV object, or none. Use the default CV strategy of the estimator. Outputs. Support a Boolean array indicating which features were selected. Ranking, an array containing the ranking of each feature. 1 is the best. Steps. Initialization. The feature selection process starts with either an empty set of features for forward selection or with all features for backward selection. Feature evaluation. For each iteration, the algorithm evaluates the performance of the estimator with the current set of features using the specified scoring function and cross-validation. Feature selection based on the performance evaluation. The algorithm selects the feature that leads to the best improvement, forward selection or removal. Backward selection in the score iteration. The process repeats until the desired number of features is selected. Metrics. Scoring metric used for feature evaluation. Examples include accuracy, precision, recall, F1 score, AUC, etc. Cross-validation score, e.g., mean accuracy across different iterations. Visualization plots. Feature importance plot visualizes the importance of each feature in the final selected set. Feature selection path plot shows the selection process, including the features added or removed at each step. Fine-tune parameters. N features to select controls the number of features to be selected. Direction specifies the direction of feature selection, forward or backward. Scoring allows customization of the scoring function used for feature evaluation. CV enables control over the cross-validation strategy. Uncertainty methods. None. Sequential feature selector is a deterministic algorithm, so there is no inherent uncertainty in the selection process. Challenges and fixes. Challenge 1. Overfitting. When the dataset is small or noisy, the selection process might lead to overfitting. Sample use case. A dataset with a small number of samples and many features, where the scoring function is highly sensitive to noise. Fixes. Increase the number of folds in cross-validation. Use a regularization technique in the estimator, e.g., L1 or L2 regularization. Perform feature selection on a larger dataset or use techniques like bootstrapping to estimate the uncertainty. Challenge 2. Feature interaction. Sequential feature selector does not consider feature interactions, so it might miss important features that are only relevant in combination with other features. Sample use case. A dataset where the prediction is heavily influenced by the interaction of two features, but each feature individually has low predictive power. Fixes. Use a more complex feature selection method that considers feature interactions, such as recursive feature elimination with cross-validation RFECV or a feature selection method. Based on a tree-based model. Create new features that capture the interaction between existing features. Challenge 3 Feature Importance vs. Feature Selection. Sequential feature selector focuses on feature selection based on performance improvement, but it might not accurately reflect the true importance of features. Sample use case: a dataset where a feature is highly important but does not significantly improve the performance when added to the existing set of features. Fixes: use other feature importance methods, e.g., permutation importance, SHAP values to complement the feature selection results. Consider using a feature selection method that is based on feature importance instead of performance improvement.